example 5 here, and we bump into the 0 to the 0th power indeterminate form. And so we're going to look at this example here and this example. We're obviously going to look at them in order because knowing the first limit is going to help us when we do the second limit. Yeah? Okay, cool. Now, to get started, what we're going to do is rewrite x to the x power slightly differently by exploiting the property that e to the ln of x is equal to x. And that's, again, true because e to the x and ln of x are inverse functions of one another, yeah? Cool. Now, this is exactly the same kind of rewriting that we had done in example 3, right? In a slightly different context. Anyway, so using this property here of e and ln composition, we could write that x to the x power is the same thing as e to the ln of x to the x power, which in turn we could write as e to the x times ln of x power. So then that would allow us to rewrite our question here as this limit here as the following, which is limit as x goes to 0 of 0 from the right, and I should add, no pun intended, of e to the x times ln of x, right? Okay, cool. All right. So then next what we're going to do is use a limit property, which is that for continuous functions, limit x goes to a of f of g of x is the same thing as f of lim is x goes to a of g of x, right? And this property of limits we've also used in example 3. But yeah, just in case you haven't watched example 3, I did it again. But yes, using this property of limits, then we could write that what we've got is the same thing as e to the, and then its lim is x goes to 0 from the right of x times ln of x. Now, as x goes to 0 from the right or from the left, we're going to get 0. So what we're going to have is e to the 0 times, what about ln of x? What happens is x goes to 0 from the right of ln of x. Well, here's a graph of ln of x, or a portion of the graph of ln of x, and it's x goes to 0 from the right. Clearly, ln tends towards negative infinity, right? So we've got 0 times negative infinity here. Now, in an earlier example, we'd gotten 0 times infinity, and I said that's a good place to be because we can always write 0 times infinity as 0 over 0. And same thing with 0 times negative infinity. It's very easy to rewrite it so that it turns into 0 over 0 indeterminate form. So we're happy that we've seen 0 times negative infinity because, yeah, as I said, it's pretty easy to rewrite as so that it adopts the 0 over 0 form. And we're going to do that by doing this, which is we're going to write x times ln of x, right? What we just had here, right? Remember, that was an equal sign. We're going to rewrite it as ln of x divided by 1 over x, right? Because ln of x divided by 1 over x is the same thing as x times ln of x. This writing was kind of poor. Divided by 1 over x. This is the same thing as, this here is the same thing. Well, sorry, let me be more specific. This here is the same thing as that. Yeah? Cool. So mirror rewriting. But then now, if we evaluate the limit, what we're going to get is e to the ln of 0 from the right is going to be negative infinity, as we'd already said, divided by 1 over x is x goes to 0. From the right is going to be going towards infinity. So we have the infinity over infinity situation. Cool, so that we could apply L'Hopital's rule. And so let's do that. Applying L'Hopital's rule, we can write that what we have is e to the limit as x goes to 0 from the right of the derivative of ln of x is 1 over x. So we have 1 over x, and then divided by the derivative of 1 over x is negative 1 over x squared. And if we simplified that cumbersome quotient there, right, this ugly looking quotient, then what we're going to get is negative x squared divided by x, which is simply negative x. So we just have this. And as x goes to 0 from the right or from the left of negative x, we're going to get 0. So what we have is going to turn into e to the 0th power. And therefore, 1. Cool. So that's the answer to this limit. This first limit is going to equal 1. But what about our second limit? Well, we'll find out soon enough, right? So for the second limit, let's erase the stuff here and do it in red, I suppose. And recalling that this very first limit we just found is 1. The second limit, we can proceed in very similar fashion and first rewrite as, and this is what I'm talking about this time, rewrite as limit as x goes to 0 from the right of, and then it's going to be this time e to the x to the x ln of x. I'm skipping a few steps, but you should be able to follow just fine. And so we can write this as e to the limit as x goes to 0 from the right of x to the x times ln of x. And so this is going to equal e to the limit of x to the x as x goes to 0, which we just did, is 1. So we have 1 times, and then limit is x goes to 0 from the right of ln of x. We've already talked about that. That's negative infinity. So we have e to the negative infinity, which is the same thing as 1 over e to the infinity, which goes to 0. So the second limit is 0, but the first limit is 1. Yeah? Cool. All right, keep watching. Take care.